Hello, math students. Welcome back to Module 11, Geometry. This is Lesson 7 called Drawing Parallelograms and Triangles. Drawing parallelograms and triangles. So our goal for today we are going to use different tools to draw parallelograms and triangles. The question that I want you to be thinking about is, what is your favorite tool to use to draw geometric shapes? So this is an opinion question. No right or wrong answer. It's just, what is your favorite tool? The things that I want you to know are, we use tools to draw different shapes. The tools can also be used to prove certain shapes. And then a set square is used to draw and prove parallel lines. So those are things you have to know and to keep in mind when we're doing this lesson today. What shapes can be made from parallel lines? Well, if you paid attention in the last lesson, we answered that question for you, so you should be able to remember what shapes can be made from parallel lines. Obviously, the first one is rectangles. Okay. The second one is parallelograms. And now I can spell it correctly if I didn't last time. And then the third one could be a square, right? Another one that we said is that you can also do trapezoids. Okay, so those are some shapes that can be made from parallel lines. What shape can be made from a rectangle or a square? So if we already have a rectangle, and remember a rectangle, the definition of a rectangle is two sets of parallel lines that are connected, but one set is obviously larger than the others. So these are parallel right here, if you notice that. Those are parallel lines. And these are parallel here, and they are a little bit longer. The other thing that you remember about a rectangle, because it's two sets of parallel lines that intersect, they have to intersect at a 90-degree angle because that's what makes them a rectangle. So the question is, what shape can be made from a rectangle? Well, do you see anything that I could do to this rectangle and have another shape that comes out of it? And hopefully you guys are all seeing it. If I was to draw a diagonal line connecting corner to corner, there is now a new shape that is created, and there's actually two of them. And the new shape that is created is a right triangle. And the reason that we know it's a right triangle is because rectangles have to have right angles in all corners, and when you divide the triangle or the rectangle in half diagonally, it keeps that right angle in the corner intact. So that becomes a right triangle. And I'm pretty sure that if we did that with a square, you would have the same thing. So the difference between a rectangle and a square is it's two sets of parallel lines, and this one's not going to be perfect, I apologize. Try a little harder, make it a little bit more. If I had my set square, then I could make it perfect. But it's two sets of parallel lines that are exactly the same length, and they're equidistant from each other because the parallel lines that are running vertically intersect with the parallel lines that are running horizontally, and a perfect square is formed. And then when you have that, if you were connecting the corner to corner here, the difference between a square and a rectangle is the rectangle is a right triangle. This one is a right triangle, but it's also something else. So in the rectangle, we have a right triangle that is formed. Everybody can see it. And in the square, when you run the diagonal from one corner to the other, you actually still get a right triangle, but it's different because we have the same distances on both sides. So when you have the same lengths on both of the sides, this is actually called an isosceles triangle. And it actually could be an isosceles right triangle because we have that 90-degree angle in the corner. And so this is an isosceles right triangle. Okay, and I don't know if that's how you spell isosceles. I apologize, but I think it is. So this would just be a right triangle. This would be an isosceles right triangle because squares, it's known that all four sides have the same length. Okay, the diagonal isn't always the same length, but the sides are definitely all the same length. And so this would be what we call an isosceles triangle. Okay? how do you know if the shape is identical? So what you have to do is you have to use the tools to help you decide if they have important information that would tell us that they are identical. So again, going back to those tools, we could use the ruler and measure the length of this right triangle and measure the length of this right triangle, and then we could compare it. Is this the same length as this? Is this the same length as this? And it automatically is, because they had to be the same size in order for the shape to happen to begin with. But if I was to draw another rectangle, then you have to ask yourself, well, how do we know if they're identical if I draw another one? The only way that we know is they have to have same side lengths. That's one way. Same side lengths is one way. Another way to tell is if they have the same sized angle measures, right? Because if their angle measures are the same, then they have to be the same size, because you can't create a different size triangle necessarily. Sometimes you can with different angle sizes. Sometimes it's a little bit different, but you'll learn that in a little while. So looking for same side lengths and same size angle measures, that helps us to figure out if they're identical or not. Okay? All right, so the last thing that we're going to do with drawing parallelograms and triangles, this is actually technically a parallelogram that is not slanted. That's how we get away with, I didn't actually draw a parallelogram. But what I would like you to do is you're going to use your set square, and it says draw a shape with your set square. One of your shapes that I want you to draw, I'm giving you an assignment, is I want you to draw a parallelogram with your set square, because it's fun. And then parallelogram. And then after you draw the parallelogram, I want you to answer this question. Can you turn it into a triangle? It'll be interesting to see what you come up with. All right, so our goal for today. Today we are going to use different tools to draw parallelograms and triangles. And then an opinion question. What is your favorite tool to use to draw geometric shapes? And then you need to make sure that draw a shape with a set square. One of them has to be a parallelogram, and then I'm giving you permission to get creative and draw whatever other one you would like to. And then see if you can turn it into a triangle. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.